Alright, so today we're going to do a couple problems off the guided practice on page 58. This is lesson 6 of chapter 1. We're going to be solving proportions. So what I see here is a ratio equal to a ratio. So that is a proportion when we look at it. K is to 7 as 32 is to 56. And sometimes you might see something obvious, like they probably took 7 times 8 to get to 56. So I could just reverse that, and 32 divided by 8 is going to be K. So I already know K is going to be 4 because this is a relatively easy problem. But there's some other things I want to make sure that you understand how to look at this in case it becomes a little more difficult where it's not obvious. So one thing you can look at is you can say, well, I can do this as a unit rate problem. I could shrink the bottom to be 1 and then grow it to be 7. So if I shrank this to be 1, it'd be taking 32 divided by 56, getting an ugly decimal, and then taking it times 7 to then grow it out to 8. That's one way we can do it. It's called a unit rate idea of taking it down to 1 on the bottom, growing it out to 7. So basically shrinking it proportionally so then we can grow it proportionally to something that fits there. All right, another way is to do what is called the cross products theorem. So here's one thing about proportions you should know, and that is, like, I'll take it easy. 1/2 equals 5/10. Everybody knows that one. If I do that, then the cross products, 2 times 5, are equal to the other cross product, 1 times 10. And that's true of every proportion out there. So if I know that, then I can look at this and say, well, then K times 56, let me write that as 56K, is equal to 32 times 7. Well, if I did 32 times 7, I'd get 224. And that just sets up a one-step algebraic equation. So I could divide by 56 on both sides, because I have to undo what they did and keep it balanced, right? Canceling out, so that means K equals 4. There's one way to solve it. Notice, they don't a lot of times want us to teach this shortcut, which is, if you notice, you'll take the two that are diagonal from each other, multiply them, and then divide by the one that's diagonal from the unknown. They don't like to teach us that, cross, multiply, and divide, or don't like us to teach that, excuse me. But you're really doing essentially the same thing, you're just doing it in a different order. So notice, we would be multiplying and dividing, right? Multiplying and dividing. Down here, we're going to be dividing and then multiplying. So not a big deal. Okay? Same kind of understanding as that whole unit rate idea of dividing by 56, then multiplying by 7. Multiplying by 7, dividing by 56. Okay. So that helps us a little bit more when we get into these ones that don't come out even. First of all, if I went to a unit rate of 1, it doesn't help me. I need to go to a unit rate of on the top. That confuses some people. 5 doesn't easily go into 41, so if we skip straight to that cross products idea, 41 times 2 is 82. 5 times x is 5x. We're in a one-step equation. So whatever they did, we undo. Divide by 5, and we get x equals 16.4, and we have our answer. Okay? All right, so let's try another solving of a proportion. This time we're going to do it from a story problem number 4. I'm just going to read it to you. Trina earns $28.50 tutoring for 3 hours. Once again, order matters. So I've talked about how dollars goes on the top and time generally goes on the bottom. So 3 hours, she earns $28.50. I write it as a rate. Okay. But what they really want me to do is they want me to write it as an equation relating her earnings, M, to the number of hours, H, she tutors. Well, how do I get how much she earned? I take whatever she's earning each hour times the number of hours. And this will always work no matter how many hours she works. So I don't really want to know how much for 3 hours or 7 hours. I really want to know how much she's earning per hour, a unit rate. Once again, we can multiply the diagonals and divide by this one. But this is a unit rate problem, so you know what? Two things on top of each other means divide. Let's just divide and change it to 1 hour. So if I divide those, I get $9.50 per 1 hour, and that is $9.5 for every hour. So let me show you what that looks like as a table then. So let's say she works several different sets. What if she works 0 hours? 0 times 9.5 is 0. By the way, that's proportional, that 0, 0 idea, right? Origin. If she works 1 hour, 1 times 9.5 is 9.5. If she works 2 hours, 2 times 9.5 is 19. If she works 3 times 9.5 is 28.5, which is what we had. And this will work for any one you want. So if you want to know in 37 hours how much money she's going to have, how many earnings, 37 times 9.5. All right, so let's take it into a graph idea. All right, well, let's plot these as points. 0 on the hours gets you 0 on the earnings. There's that point. 1 on the hours gets you 9.5 on the earnings. 2 on the hours gets you 19 on the earnings. 3 on the hours gets you 28.5 on the earnings. And if you graph that properly, it would be going through the origin, 0, 0. Here's your constant of proportionality. 9.5 for every hour, up 9.5 for every hour, up 9.5 for every hour. So here's what it looks like as a graph. Here's what it looks like in a table. Here's what it looks like as an equation. Here's what it looks like as a unit rate. And the whole thing then would be as a proportion.